I'm ready.
Okay, so the bottom of the integral is 1. The top is 9. And it's 8 plus x squared over square root of x.
Is it in, I didn't hear you. Is it in parentheses?
The whole, that's the numerator. And it's over square root of x.
Oh, I see what you mean. Okay. So this is when the denominator is one term. You can say, you cannot call this a term because it's not part of a polynomial. Okay, one quantity, right? If it's one quantity, you will always separate it as 8 over the square root of x plus x squared over the square root of x. So we had examples like this. So at this point, I have the integral from 1 to 9, and this is 8x to negative 1/2, and 2 minus 1/2 is 3/2. Is that okay so far?
Yeah.
We don't know how to do more than just this yet. You will learn different procedures in Calc 2. But this is a simple situation in which we always separate the fractions. So then I have 8 to x to negative 1/2 plus 1, which is 1/2 divided by the same thing. And x to 3/2 plus 1, which is 5/2 divided by the same thing. And this is from 1 to 9. And I will try to simplify as much as possible. So when I flip this, I get 16. And this is the square root of x. I flip this and I get 2/5. And this is the square root of x to the 5th. I can write it like this. From 1 to 9, because it's easier for me. I'm kind of lazy sometimes with the calculator. Okay, so the square root of 9. So this is 16 multiplied by 3. And this is plus 2/5 multiplied by 81 and then multiplied by 3. But now minus, careful, when I plug in 1, I get 16. When I plug in 1, I get 2/5. And now I have to see what this means. So 48 plus, oh, okay. What is it? 81 times 6. So 486 divided by 5 minus 16 minus 2/5. So 48 minus 16, that is 32. And 486 minus 2 is 484 over 5. So 32 times 5 plus 484. 644 over 5. Was this from WebAssign or?
Yeah.
Is this better now?
Yeah, that's fine. I guess I didn't know if you should always split it up.
Oh, yeah. Oh, yeah. Yeah. If it's like that. But if you have something like, let's say, 8 plus x squared over the square root of x plus 1, you cannot separate.
Right. Okay.
Good. Next question.
Okay, I have another question. So sometimes I feel like with substitution rule, I don't know what the goal is almost.
You don't know what is what?
What like the goal? Like, I don't know what I guess you're trying to just simplify.
To find the exactly, to find the correct substitution. Is that?
Yeah. I just kind of lose track of like what I should be doing.
So it's okay to start with something you think it should be your substitution. If you're not getting anywhere, it's okay to go back and try a different one. So that is not a mistake. It's okay till you get used to it. I'm ready.
Okay, so it's an integral and the function is 2t plus 7 in parentheses, and that whole thing raised to the 2.8.
Like this?
Yes.
Dt.
Yes.
Okay. So obviously what bothers me is this raised to that. So I'm going to say let y be 2t plus 7, as long as dy is in the problem, or I can make it up. I cannot make up functions, but I can make up numbers. Is this okay?
Yeah.
So I have the dt, but I don't have the 2. Who cares? That I can make up. Multiplying by 2 and divided by 2 is 1. I'm not changing anything. So then I have 1/2. This piece changes into y to 2.8, and this changes into dy. And this simplifies the integral tremendously, because I have 1/2 y to 2.8 plus 1 over the same number plus a constant c. So what is this? 7.6. And y gets changed back to 2t plus 7 raised to 3.8 plus a constant c. You can always, in an indefinite integral, you can always differentiate this, and you will definitely get the original function, guaranteed. Which we cannot do with this. I can only hope for the definite integral. But for the indefinite integral, just differentiate this. It's guaranteed to get 2t plus 7 to 2.8 and nothing else, the original function. That is the best thing for you, to try things and look at the lecture notes and then come back and talk about it. That is how we learn and how we make progress. Very good. Who is next, or what is next?
I have a web assign problem.
Yes? Do I have to bring it up?
Yeah.
Okay, I'm gonna bring it up, sorry. Wrong keyboard. Isn't that nice when you type it and nothing happens? So sorry, it's a slower computer. And I won't tell you how old it is. Well, I probably told you. Okay, I am finally in.
It's 5.4, number 8.
5.4, number 8. Okay. I'm going directly to your problem, so we do that particular one. 5.4. Okay, number 8. 1, 2, 3, 4, 6, 7. Where are you? 8. I see it. Okay. So I think it is, always check what I copy, because my devices are so far away from me, I may not see correctly. So 1/2, I see t to the 5th plus 1/4 t to the fourth and minus t dt. Is that okay?
Yeah, that's it.
Okay. So 1/2 t to the sixth over 6 plus 1/4 t to the fifth over 5 minus t squared over 2. Everything from -2 to 0. I will clear it up a little bit before I plug in the numbers. So 1/12 t to the sixth plus 1/20 t to the fifth and minus t squared over 2. Okay. Okay. When I plug in 0, it's all 0, but I cannot forget about the minus. When I plug in -2, 1/12, 2 to the sixth, minus 1/20, 2 to the fifth, and this is 4/2 is 2. So let's see if I do need a calculator. I may not. So negative 64/12, but plus 32/20 and minus 2. Minus plus plus. Okay. Can I simplify a little bit? Yeah, by 4, 16 and 3, by 4, 8 and 5, and plus 2, 15. So 5 and 3 and 15. So negative 80 plus 24 and plus 30. So 50, so negative 80 plus 54 over 15. So I get negative 26/15. Yep. Is that okay?
Yeah, so could you also keep the negative like in front and then calculate everything inside the parentheses and just
Of course.
okay.
Of course.
I have another question for the same section,
Yes.
number 12.
Yes. 10, 11, 12. I see it. So the integral from 0 to 1, I think it's x to the 13th plus 13 to the x dx.
Yes.
Okay, perfect. So remember, I forgot to say, but we always have to check, make sure that the function is defined here. It's continuous here between -2 and 0, and it is. This is always continuous, but we always have to check. So this is x to the 14th over 14th plus 13 to the x divided by natural log 13. So let me refresh our memory on this before I continue. So when we differentiate e to x, we get e to x. I should write times natural log e, but I don't because it's 1. So if I have 13 raised to x prime, I have to write 13 to x times natural log of 13 because this is not 1. When I go back, this goes to the denominator. So when I integrate this, I get 13 to the x over natural log 13. So let's stop for a moment and check if you want to differentiate this, because I want you to remember this, not just memorize it, understand it. So when I differentiate this, I bring 14 down, it goes away, and I subtract 1 from the power. And how do I differentiate? This is a constant. It stays in front. But how do I differentiate 13 to the x? is 13 to the x times natural log 13, which will disappear with this. And that's how I get the 13 to the x. Is that okay? Before we continue.
Yes.
Okay, so then when I plug in 1, I have 1 over 14, and then plus 13 over natural log 13. When I plug in 0, this goes away, but minus, when I plug in 0 here, this is 1 over natural log 13. And now I have to combine like terms. 1 over 14 stays in front. So we have 1 over 14, but 13 minus 1 is positive 12 over natural log 13. And this is final. Is this clear?
Yes. So the antiderivative of a constant raised to like x is
Yes. So
it's just-
yes. So if you want to integrate a constant raised to x dx, you get a to the x divided by natural log a plus a constant c. And
okay,
we can check by differentiation. Check by differentiation. So when I differentiate this side, I get a to the x. When I differentiate this side, I get a to the x times natural log a divided by natural log a, goes away, and this is 0. And I get a to the x equals a to the x.